All right, let's dive in. Today we're exploring something called perfect hashing.
Perfect hashing.
Yeah, it helps make AI and image processing crazy fast, especially on those powerful GPUs everyone's talking about.
It's pretty amazing how this seemingly niche concept is actually quietly powering us so many things we use every day.
Oh, really?
Yeah, from Google Translate to like detecting collisions in those super realistic video game worlds.
Oh, wow.
Perfect hashing is everywhere.
So what is perfect hashing? It sounds kind of, I don't know, intimidating,
Uh,
but I'm sure you're going to break it down for us.
Absolutely. Think of it like this. Imagine a library where you know the exact location of every single book.
Okay.
No more wandering the aisles, no flipping through card catalogs.
All right.
That's the essence of perfect hashing. It's a lookup table where every single piece of data has its own unique, predetermined spot.
Okay, so no more digital traffic jams when our computers are trying to find information. I'm starting to see why this is a big deal, but how does perfect hashing actually work? Is it some super complex algorithm?
Well, the magic happens because with perfect hashing, you know all the books or data points you're going to need to store ahead of time.
Okay.
This lets you create a special function that guarantees each piece of data gets its own unique slot in the table.
So it's like having a personal librarian who just knows exactly where everything is.
Exactly.
Which makes searching super speedy. But I'm guessing there are some trade-offs, right?
Yeah.
Like, when wouldn't you use perfect hashing?
You're right. It's not a one-size-fits-all solution. Perfect hashing works best when you have a fixed set of data.
Oh,
If your data is constantly changing or growing, it might not be the best fit. Think of it like trying to organize a library where new books are coming in all
yeah,
the time.
that'd be a nightmare.
It would be chaos.
Yeah. But for things like dictionaries used in language translation, or maybe image databases where the data is relatively stable, perfect hashing seems like it could be a real game changer.
Absolutely.
So how does this tie into the world of GPUs? I know they're all about parallel processing and handling tons of visual data.
That's where spatial perfect hashing, or SPH, comes in.
SPH.
Yeah, GPUs are like teams of chefs working in parallel.
Okay.
And they need all their ingredients organized just right for maximum efficiency.
Okay, I'm intrigued.
Good.
So how does SPH help those GPU chefs do their thing?
Imagine a chef with all of their ingredients prepped and laid out within easy reach.
Okay.
That's good locality.
Okay.
Everything is close by, and they don't have to waste time running around the kitchen searching for stuff.
That's a perfect analogy. I can already see how that would speed things up in a kitchen.
Exactly. And SPH arranges data in GPU memory so that related pieces are stored near each other. This reduces the time the GPU spends searching for what it needs, which is a major bottleneck for these powerful processors.
So SPH is like a super efficient kitchen organizer for GPUs,
Precisely.
ensuring they can access data quickly and easily.
That's it.
That makes perfect sense. But can you give us an example of how this actually works in practice?
Sure. Think about image processing. Each image is made up of millions of pixels, and SPH can arrange those pixels in a way that makes them super easy for the GPU to process.
Okay.
Especially for tasks like object detection or image segmentation. It's like having all the pieces of a puzzle laid out neatly so you can see the bigger picture instantly.
That's fascinating. So SPH helps GPUs understand the relationships between pixels and process them more efficiently.
Got it.
It's like having a superpower for visual data.
It really is.
Yeah.
And this applies to AI, too. Neural networks, which are the brains behind a lot of AI, have massive amounts of interconnected data. SPH can optimize how that data is stored in memory, which makes training those networks much faster and more efficient.
Okay, so perfect hashing, and specifically spatial perfect hashing, are playing a crucial role behind the scenes, making our AI and image processing applications lightning fast. But I'm curious, once you have this perfectly organized table, how do you know which slots actually have data in them? It's like having a giant library with millions of shelves. How do you know which ones actually hold books?
That's a great question. It brings us to the concept of sparsity encoding. Since perfect hash tables are often designed to handle a very specific set of data, there can be a lot of empty slots. Sparsity encoding is all about efficiently indicating which slots have data without adding a ton of extra overhead.
So it's like having a system where you only label the shelves that have books on them,
Precisely.
saving you from having to check every single one. Genius.
Exactly. There are a few different ways to do this, each with its own trade-offs, but the core idea is to represent that emptiness efficiently, so you're not wasting precious memory space.
It's incredible how much thought goes into making these systems work smoothly. So we've got our perfect hash table, and we know how to efficiently indicate which slots hold data. What's next in our deep dive into the world of perfect hashing and GPUs?
Well, next we can explore how to handle smooth transitions between those data points.
Okay.
This is especially important in things like image processing, where you don't want images to look blocky or pixelated.
That makes sense. So we're talking about filtering and how to ensure a smooth flow of information.
You got it.
Tell me more.
Yeah, filtering is all about creating those smooth transitions between data points. It's like blending colors in a painting, to
Yeah.
get those gradients instead of harsh lines.
Yeah. Okay, so filtering makes things look nice and smooth, but how does that work with these blocks of data we were talking about?
Great question. There's a couple of approaches. One is called blocking,
Okay.
where you divide the data into smaller chunks or blocks. This lets the GPU apply its built-in filtering capabilities more efficiently.
So blocking is kind of like breaking things down into bite-sized pieces for the GPU to handle more smoothly.
That's a great way to put it.
What if you don't want those blocky artifacts?
Right.
I'm guessing that's where explicit filtering comes in.
You got it. With explicit filtering, you're basically doing the filtering calculations yourself in software,
Okay,
which gives you a bit more control over the process, but it can be a bit slower on current GPUs.
so there's a trade-off there between leveraging the GPU's hardware acceleration and having more fine-grained control.
Exactly.
Interesting. But how does perfect hashing fit into all this filtering business?
Well, when you're working with these blocks, you need a way to manage the relationships between them.
Yeah.
Which blocks are neighbors, where they're located in memory, that kind of thing.
Right.
Traditional methods use these things called indirection tables, which can get pretty big and clunky,
Uh-huh.
but perfect hashing offers a much more compact and efficient way to manage this block indirection.
So it's like having a super organized index for our blocky world, making sure everything is easily accessible.
Exactly.
I love how perfect hashing keeps popping up as a solution to all these different challenges. But before we move on, can you give us some real-world examples of how perfect hashing and SPH are being used in those applications we talked about earlier, like Google Translate or DNA sequencing?
Absolutely. In Google Translate, perfect hashing helps speed up the process of looking up words and phrases in their massive dictionaries.
Wow.
It's like having instant access to a multilingual encyclopedia. Makes translations much faster and more seamless for you.
That makes sense. It's all about finding those words quickly, and perfect hashing seems like the perfect tool for the job. What about DNA sequencing? How does perfect hashing help us unravel the secrets of the genome?
Well, DNA sequencing involves analyzing massive amounts of genetic data. Perfect hashing helps create efficient lookup tables for DNA sequences, which lets researchers quickly compare and analyze those sequences to identify patterns and variations.
So it's like having a super fast search engine for the building blocks of life.
That's a great analogy.
Incredible. But let's not forget about those amazing 3D simulations we see in video games and movies. I'm guessing perfect hashing plays a role there too.
You bet. Collision detection, which is crucial for making those simulations look realistic, involves constantly checking if objects are intersecting. Perfect hashing, especially SGH, helps by organizing the data representing those objects in a way that makes those collision checks incredibly fast.
So instead of checking every single object against every other object, perfect hashing helps narrow down the possibilities, saving a ton of processing power.
Precisely.
It's like having a traffic controller that prevents digital gridlock.
That's a great way to put it. And because SPH can be implemented on the GPU, it takes advantage of all that parallel processing power, making those simulations run even smoother and faster.
Okay, so we've seen how perfect hashing is speeding up language translation, DNA sequencing, and even making those incredible 3D worlds possible. It's amazing how this one concept has such a wide range of applications. But I'm curious, are there any limitations to perfect hashing? Is there anything it's not good at?
Well, as we mentioned earlier, perfect hashing works best with static datasets where the data doesn't change very often. If you're dealing with data that's constantly changing, like in a real-time system, perfect hashing might not be the most efficient choice.
That makes sense. It's like trying to organize a library where people are constantly bringing in new books and rearranging the shelves. You'll be a nightmare.
Exactly. In those cases, other data structures might be a better fit, but researchers are always working on new ways to make perfect hashing more dynamic and adaptable.
So even with those limitations, it sounds like perfect hashing is a crucial tool for anyone working with large data sets, especially in areas like AI and image processing. But before we wrap up our deep dive, I'd love to get your perspective on the future of perfect hashing. Where do you see this technology heading in the years to come?
That's a great question. I think we're only just beginning to explore the full potential of perfect hashing. As the amount of data we generate continues to explode, and as new hardware like specialized AI chips and even quantum computers become more prevalent, perfect hashing will become even more important for managing and processing information efficiently.
It's exciting to think about how perfect hashing will continue to evolve and what new possibilities it might unlock. But before we get too carried away, I want to bring our focus back to you, our listener. Why should you care about perfect hashing?
Even if you're not a computer scientist, just understanding the basic concepts of perfect hashing and data locality can give you a much deeper appreciation for how the technology you use every day actually works. From your smartphone to the internet to the AI systems that are becoming increasingly integrated into our lives, perfect hashing is playing a vital role behind the scenes, making those experiences faster, smoother, and more efficient.
It's like having a glimpse behind the curtain of the digital world.
Exactly.
And who knows, maybe learning about perfect hashing will spark your own curiosity and lead you down some fascinating paths of exploration. But for now, let's wrap up our deep dive with one final thought-provoking question for you to ponder. As GPUs and other processors continue to evolve at a breakneck pace, how might techniques like perfect hashing need to adapt to keep up with those advancements? Could we see a future where perfect hashing is baked into the very hardware of our devices, leading to even more incredible leaps in performance?
Those are fantastic questions to consider. The future of perfect hashing is really intertwined with the evolution of computing itself. As we demand more from our devices, and as those devices become more powerful and complex, perfect hashing will undoubtedly play a crucial role in shaping that future.
Well, on that note, it's time to wrap up our deep dive into the world of perfect hashing. We've journeyed from the theoretical foundations to real-world applications, and we've even glimpsed into the exciting possibilities that lie ahead. Hopefully you've gained some valuable